Our story begins about 4.6 billion years ago. Back then, our solar system was just a vast cloud of gas and dust, a nebula drifting through the cosmos. Gravity began to pull this material inward. As the cloud contracted, it spun faster and faster. The center grew denser and hotter. Eventually, hydrogen atoms began to fuse, releasing energy. Our sun was born. Surrounding the sun, a protoplanetary disk continued to orbit. This disk would become the birthplace of our Earth and other planets. Within the swirling protoplanetary disk, a remarkable process began: accretion. This process started with tiny particles of dust, remnants from the solar nebula, colliding and sticking together. Imagine these dust grains as cosmic marbles bumping into each other in the vastness of space. Over millions of years, these collisions created larger and larger clumps of matter. Gravity played a crucial role, pulling in more material and accelerating the growth of these clumps. As these clumps grew larger, their gravitational pull intensified, attracting even more dust and gas from the surrounding disk. These growing objects, called planetesimals, became the building blocks of planets. In the inner region of the solar system, where Earth formed, it was too hot for volatile substances like ice to survive. The planetesimals here were composed mainly of rock and metal, materials that could withstand the intense heat. Through relentless collisions and the ever-present force of gravity, these rocky planetesimals coalesced to form our planet. Earth, still in its infancy, was about to experience a cataclysmic event that would shape its destiny and give rise to its faithful companion, the Moon. Enter Theia, a Mars-sized protoplanet, also forming in the early solar system. In a cosmic twist of fate, Theia's path crossed Earth's orbit, leading to a colossal collision. Imagine the unimaginable: two planetary bodies, still molten and glowing, smashing into each other with incredible force. The impact was so powerful that it sent a vast amount of debris hurtling into space. Some of this debris fell back onto Earth, while the rest remained in orbit, bound by gravity. Over time, this orbiting debris coalesced, drawn together by its own gravity. Gradually, it formed a single celestial body, our Moon. The Moon's formation had profound implications for Earth. Its gravitational pull stabilized Earth's rotation, preventing wild swings in our planet's axis and creating a more stable climate. This stability would prove crucial for the emergence and evolution of life. After the fiery chaos of its formation and the dramatic impact that birthed the Moon, Earth began a long process of cooling. The molten surface, a sea of magma, slowly solidified, forming a thin primordial crust. However, the planet's interior remained incredibly hot. Volcanoes erupted frequently, spewing lava, gases, and water vapor into the atmosphere. Imagine a landscape dominated by fiery volcanoes, spewing molten rock and lighting up the sky. As Earth continued to cool, water vapor in the atmosphere condensed, forming clouds. Torrential rains lashed the planet's surface, filling the first basins and creating the early oceans. This constant cycle of volcanic activity and rainfall played a crucial role in shaping Earth's early environment. It also set the stage for the next chapter in our planet's story: the emergence of life. Section 5. Life finds a way, the first oceans stir. In the depths of Earth's newly formed oceans, a profound event was about to unfold: the spark of life. The exact details of how life arose from non-living matter remain a mystery, but scientists believe it occurred in these early oceans, teeming with chemicals and bathed in energy from the sun. Imagine these primordial seas, a chemical soup where simple organic molecules, the building blocks of life, began to assemble. These molecules, formed through complex chemical reactions, eventually gave rise to the first self-replicating entities, the precursors to life as we know it. These early life forms were simple, single-celled organisms, vastly different from the diverse life we see today. Yet they possessed the remarkable ability to reproduce, passing on their genetic information to future generations. This marked a pivotal moment in Earth's history: the transition from a lifeless planet to a living one. Section 6. A planet transformed, the rise of continents and life. Over billions of years, Earth's surface evolved. Tectonic plates moved, driven by the planet's heat. Plates collided, creating mountains, valleys, and trenches. Volcanic eruptions shaped the landscape, and life began to emerge. Early photosynthetic organisms released oxygen. Oxygen transformed the atmosphere, enabling complex life. Continents drifted, forming supercontinents. These movements diversified life. Oceans rose, climates changed, and life evolved. Section 7, A World of Wonders, Earth's Diverse Landscapes. Fast forward to the present day and we find Earth adorned with a breathtaking tapestry of landscapes, each sculpted by the forces of nature over eons. Towering mountain ranges pierce the sky, their snow-capped peaks a testament to the power of plate tectonics. Vast deserts stretch across continents, their sand dunes sculpted by wind and time. Lush rainforests teem with life, a symphony of colors and sounds, while icy polar regions shimmer with an otherworldly beauty. From the depths of the oceans to the heights of the Himalayas, Earth's landscapes are a testament to the planet's dynamic history and the interplay of geological processes, climate, and life itself. Each landscape harbors unique ecosystems, intricate webs of life adapted to their specific environments. Coral reefs teem with colorful fish, while grasslands support herds of grazing animals. Forests provide shelter for countless species, while deserts are home to creatures adapted to survive in harsh conditions. Section 8, Our Living Earth, a precious and fragile home. It's crucial to recognize the interconnectedness of all things on our planet. The air we breathe, the water we drink, the food we eat, all are products of Earth's intricate systems. Our planet is a living, breathing entity with its own rhythms and delicate balances. From the smallest microbe to the largest whale, all life on Earth is interconnected. We depend on the planet's resources, and our actions impact its health. The challenges we face highlight the urgent need to protect our fragile home.